All right, so thank you to UtahJS for having me, and thank you to you all for showing up today. I'm really excited to talk about this year's theme, which is navigating complexity, because that's pretty much all that I do, and it's sort of the reason for htmx itself existing. So a little bit about me. Currently, I'm one of the maintainers for the htmx JavaScript library, and you can find all of my relevant info and socials at alexanderpetros.com. And I'm also, along with the author of the htmx library, one of the co-authors of the Triptych proposals, which is an attempt to bring some of the core ideas of htmx into the actual HTML standard. And we've gotten a fair amount of traction with that lately. But before I can talk about Triptych, before I can talk about what htmx is, if you're not familiar with it, we need to understand kind of the motivation behind some of these things. And for that, the only place, natural place to begin is with oh yeah, we've got some traction on these proposals. The first one was released in August this year. So the only natural place for us to begin is with the Williamsburg Bridge. So if you've never been to New York City, the Williamsburg Bridge is one of 3 East River crossings between Manhattan and Brooklyn. It's not even the most famous bridge between Manhattan and Brooklyn, which is definitely the Brooklyn Bridge, a bit to the south, a couple bridges down. But the Williamsburg Bridge is very interesting to me, and it's interesting primarily because it is the last bridge that was designed with the horse-drawn carriage in mind. So in 1892, when they were saying we need a bridge between Manhattan and Brooklyn, they wanted it to transport pedestrians and carriages and maybe a train of some kind. So since it's opened in a little over 100 years ago, we've used it for a bunch of things. We put a streetcar on it. We put a subway on it. We took the streetcars off once streetcars were no longer that relevant. We expanded the lanes. We added an ADA ramp. We converted one walkway to a bike path. We reconstructed the bike paths. We reconfigured the lanes. We have done a lot of things over time with the Williamsburg Bridge, but throughout that 100-year history, it has always been a bridge, and it has retained some fundamental bridginess that was useful around the turn of the century and remains useful today. So today it carries 8 lanes for cars, 2 tracks for the JMZ subways, a bus lane, or not a bus lane, it has a bus, there is no bus lane, and it has a special path for pedestrians and bicycles. So the Williamsburg Bridge was built during what is widely considered to be kind of the greatest period of change and human flourishing in our history. So the Industrial Revolution under full swing during the Williamsburg Bridge, and that's part of the reason why we have reconfigured what that bridge is used for so many times. But we've been building bridges for a lot longer than that. This is a photo of Trajan's Bridge, which is in northern Portugal, and it was built during the rule of the Roman Emperor Trajan in 100 CE. And if we ask ourselves, what is it that the Roman Emperor Trajan and Leffert L. Buck, the chief engineer of the Williamsburg Bridge, have in common, it's that they both agree that it would be helpful to move grounded objects across some narrow body of water. And as time changes, our techniques for building those bridges may improve, but the bridge itself is useful for future generations, it's maintainable by them, and it's adaptable to their needs. And that's a very, very interesting quality, because it should be impossible to imagine that we would be able to build something in Roman times that is still useful today. And if you look at that bridge, you can see there's actually a little car on it and a couple pedestrians. So they could not have anticipated the automobile, but nevertheless, it is being used for that today in northern Portugal successfully. So the question for today is, how do we do this, but for software? How do we build software today that is intelligible to somebody 100 years from now, useful and maintainable by them? So to do that, we should look to the past. We've been doing software for about 50 years or so, maybe a bit longer. So what do we have in common with a software engineer from 1991? And one such problem would be that it is useful to share and access hypertext documents using a uniform resource identifier. So if I give somebody a link, like I said, the name of my website at the beginning of this talk, every one of your devices, you can go to my website. So that's a useful thing that we have access to. And if you don't know who that is on the left, that is, of course, Sir Tim Berners-Lee, the inventor of the World Wide Web. Now, Tim was working at CERN, which is a research laboratory in Switzerland. And CERN today has the first website that was ever created on their own website that you can access. So if you click on Browse the First Website, you'll see something that looks like this. And this was, I think, published to the world in 1993. And it's got a couple links like explaining what is a website and how to use it and what it might be useful for. But CERN also lets you browse the first website using a line mode browser simulator. And the line mode browser was what CERN built as like a concept browser for how one might browse the World Wide Web. So this was their way of saying, hey, this thing's going to be useful, here's how you use it, and it looked like this. And this is a text user interface. And this is like you would have logged onto your terminal and logged into line mode browser, and you would have, this is the exact same web page that I just showed you in Mozilla Firefox, but in the context of the line mode browser from 30 years ago. And an interesting thing that I want to highlight about it is that the links are not denoted with blue underlines because terminals couldn't represent blue underlines. There are arrow brackets that tell you like what is the number that corresponds to that link. And then the way that you go to that link is, for instance, if you wanted to go to executive summary, the way you would do that is you would type in 2 in your keyboard and then hit enter, and then the whole screen would refresh with whatever is at the link executive summary. And this is the HTML that renders that page. And you can look at this, and this looks kind of dated to us now because there are some style conventions that we don't use anymore. We don't typically capitalize our tags. We don't typically put a line break after the beginning of the anchor, but it's still recognizably HTML, and this exact same document is what was running in the line mode browser that is also running in your current browser. So that's really remarkable. There really isn't, and this HTML really is source code, and we should think of it that way. There aren't a lot of source codes that run unmodified in software that is 30 years apart. And in this particular screenshot, I took it on my cell phone, on my touchscreen smartphone, which is a device that presumably Tim Berners-Lee had no way of anticipating. So we're able to take this exact same source code, put it in not just the new context of the familiar blue underline link that you can click that meets the needs of the interfaces that we could imagine in the 2000s, but you also have it in the context of you're not even clicking that with a mouse, you're touching it because it's on a smartphone. So this core representation of a hypertext document is adaptable to things that were not at all anticipated in 1991. So for the problem of sharing and accessing hypertext documents, solved. We did it. And with that framework in mind, we should ask ourselves, well, what problems do we have in common with the software engineers of 100 years from now? And what can we learn from the fact that we have similar problems with the software engineers of 30 years ago to build for the software engineers 100 years from now? One such problem, hypertext documents. It will probably still be important to browse Wikipedia, hopefully, 50 years from now. So the idea of a set of images and text and links that you can click that link to other documents, all of that is hopefully kind of part of the larger human heritage that we are creating on the World Wide Web right now. But we already solved that, so what are some other problems? It might be helpful to request a new government ID. A couple years ago, I needed a new Florida driver's license, and I went to the Florida DMV website, and I filled out a form, and they just mailed me a new one with a new expiration date. And that was a super smooth, easy process. It's likely that we're going to need to do some form of interaction with the government and government IDs 100 years from now, so that's a problem we might have around that time. Library books, same deal. When I was in elementary school, they taught us how to use a card catalog. Even when I was in elementary school, that was an outdated term. The card catalog was just like a computer, a desktop computer somewhere, and you would just like go to it. But that functionality is now on any website. So not only can I browse the catalog of the library from my home, I also have the ability to, as like somebody with an account on the New York Public Library, I can like rent, I can request books, I can rent movies, that sort of thing. And likewise, we're always going to need a place to live, so it will always be useful to use the internet to figure out where I can live and what are the comparison shop homes in my area. So these are just like kind of broad strokes. What are things that we might solve with the web in the next 100 years? So what we want is we want this same durability, the same I made one representation of a thing, and now it is useful, basically untouched, 50, 100 years from now, but we want that for a more interactive type of service, so something that is a little bit more functional than just a hypertext, like a static document. It's worth briefly considering whether you would do this on any of the other platforms that are available to us today. You're all at UtahJS, so presumably you have some personal investment in the web as a platform. But we can pretty much agree that if you wanted to, say, build the library card catalog as a Windows application, you would not feel like you had the same durability guarantees with the card catalog as a piece of software deployed to a Windows PC that you do with the World Wide Web. And as we try to build for these unique characteristics, it's important that we name them. So the web, it runs on every device. You probably bought more than one browser-capable device with you today. It's ridiculously backwards compatible. It has instant updates. You don't need anybody's permission to change what is on your website. You just do it immediately. And it has a lot of things about it that are competitive. Payment processing, economically, probably being the most significant, but hosting is competitive. The web has such a basic architecture that all of the various aspects of it, lots of people can build for it, and so you get kind of better economics for the things that you might want to shell out to a service. So, in the remainder of the talk, I'm going to explain how I, kind of at a basic level, build websites today, build web services with this in mind. And this is a very opinionated section of the talk, and so I'm going to talk about very specific technology choices just so that it's practical. But to the extent that you agree with some of my technology choices, but not all of them, the important part is the reasoning. And so you may have different needs, you may have different use cases, and you may decide that, when I tell you in 2 minutes not to use Postgres, you may disagree with that. But the important part is you understand why it doesn't make sense for the kind of application I'm building, and then apply that reasoning to yourself. So we have the basic web client. That's HTML, that's CSS, that's going to last for a long time. So the next most important thing that we need is a way to store what the user is doing, and that is with a database. So what database? We need something that is highly backwards compatible, that is supported everywhere, and has a very, very long expected lifespan. And the natural choice, I think, is SQLite. And if you are, SQLite on the server is having a bit of a moment right now. Lightstream is a really excellent backup technology. Fly.io is committing to it in a lot of ways. So we're already at stage 2 of people believing that you can do SQLite on a server. But still, I think the absolute best case that addresses most of the objections that you might have to this is a blog post by a fellow named Wesley Apteker Castles, and it's called Consider SQLite. And this is, I think, one of the most brilliant technical blogs of this decade. I think that the implications of server-side SQLite are not fully understood, and they won't be fully understood for a while. It enables a completely different pattern for application development, and it also enables completely different economics for what your application is able to do and what kinds of applications might be feasible to put online. But they address a lot of the specifics within the post, so I would just say go read it. But I want to, I'll kind of dig into that now, especially because whenever you tell somebody to use SQLite, you have to address the elephant in the room, which is, what about Postgres? So Postgres is kind of considered, it's open source, it's an absolutely phenomenal piece of technology, it's considered the default, in many cases, if you want to just put something online. Here's the problem with Postgres. So Postgres has had, these is the last major version releases for Postgres. So the last long-term supported version of Postgres was released in 2019. So if you built a brand spanking new web service in 2019, you are coming up on the deadline by which you need to upgrade your Postgres right about now. And 5 years is not a long time. That is a very short amount of time, especially if we are trying to build something that will last relatively unmodified for 10, 20, 50, 100 years. You'll start getting emails like this, or your IT department will start getting emails like this, or the emails like this will go to an email account that nobody has logged into for 5 years, and then one day they will threaten. They're like, we're going to upgrade you. We don't want to deal with this old unsupported version of Postgres anymore, because almost certainly if you're using Postgres, you're probably using a managed hosting service of some kind, because Postgres is usually hosted as a separate application and a separate client. And then you talk to it. So that's 2 processes you have to manage. I had to do this migration when I was working at the Washington Post. I joined with, and I was put in charge of a service that was built around 2016, and it worked great, basically, for about 5 or 6 years. And then when I joined, there was a migration that had to happen right now, because they were kicking us off of AWS was kicking us off of Postgres 9.6, so I had to upgrade to Postgres 14. This is not trivial. It's not the hardest thing in the world. It's pretty doable. There are decent tools, but it probably requires some downtime. It's a lot of, it is effort that is almost certainly going to hit you right when you would rather be doing anything else. It is a must resource, so you're going to put something aside to do this, and there's probably some director that's going to be angry about that. Now, just for comparison, let's look at the last time that SQLite did a major version release. That's right, it predates the Obama administration. So if you built a SQLite service in 2010, you're still on SQLite 3. You are still dealing with the same major abstractions. Now, there are two benefits to this. The first is that because SQLite is a library, it's not a separate process that you're running. Nobody is going to be emailing you, telling you that you need to upgrade your SQLite, because your SQLite just exists as part of your build, whatever that is. So you don't have that same degree of, like, there's somebody else's responsibility for migrating you. And it's important to state that backwards compatibility and major version, when you upgrade a major version, you're basically making a statement that you cannot expect complete backwards compatibility when you move from version 2 to version 3. So there's no, it's a judgment call what constitutes a major version increase. So every bug, if you fix a bug, and everybody agrees that it's a bug, but that bug is behavior that somebody is relying on, then you're still breaking their change, even if you don't call that a major version change. So this is a statement of values, but it's a very important statement of values, and you can see that in one of my favorite pieces of documentation on the internet, which is SQLite's quirks, caveats, and gotchas. And these are basically things that SQLite got wrong at one point in time and are now stuck with. And it includes stuff like foreign key enforcement is off by default, which is ridiculous. You would never build a new database and not enforce foreign keys. But as the documentation says, by the time that they made SQLite capable of enforcing foreign keys, there were millions of databases, and some of those would not have been correct. And so they said, fine, it's off by default forever. Again, you might say that I don't want to use something that is wrong, that is burdened with the decisions of 2005. But if I built my application in 2005, I absolutely do not want SQLite to change that foreign key default, because that might break something in my application. So it is a different set of values, but it's a very defensible set of values, and one that leads to a different set of properties for the longevity of your application. Another one, primary keys can sometimes be nulls. This is a bug, but we are supporting the buggy behavior moving forward. Okay, fine. Same with double-quoted string literals. We should not have tried to make SQLite accept MySQL. This is hilarious. Nobody does this. Nobody says we made a mistake a decade ago and we're sticking with it because not breaking your application is more important to us than making this more intuitive to new users. And as somebody who makes use of that behavior, I would much rather, at the first time I install an application, just enable foreign keys. It's just one config. I'd rather do that once, build the thing correctly, and then be confident that if there's any other built-in behavior that I didn't account for, that behavior isn't going to change on me and break my application at some point in the future. So SQLite will never do this to you, will never send you any emails. That is a Dr. Richard Hipp guarantee. All right, so that's our database. So how do we do application logic? Again, application logic meaning stuff like who's allowed to log in, who's allowed to view this web page, who's allowed to modify this web page, that sort of stuff. So again, we want to maintain as much as we can the basic properties of the web. And I think that the best way to do this is to stick as much as possible to HTTP. And what do I mean by that? I mean that you want to describe the functionality of your application to the maximum possible in a router. And this is an example from Express.js. And if you saw Corey's talk, you might note that I have disabled prettier for this file because I think it's much more scannable. So down with the tyranny of automatic code formatters. The important stuff to emphasize here is that on the left is the method that is being used for the route, post, put, delete. The next step is the actual route itself. So you can post to /trip, you can put to /trip ID. And then there's the middleware that encodes the permissions, and then there is the actual function that handles what the application does when you call that route. And we're going to talk about, I'm going to dig into those in a moment. So the stack that I use for this is Node.js with better SQLite 3. That's Joshua Wise's library. It's the best SQLite implementation for Node. It's synchronous. It's super fast. Express.js. Express.js is a clunky old technology, but it got the API correct. And Express.js has some important limitations, but fundamentally, it makes it super easy to describe in HTTP some set of routes, and particularly routes that have parameters, and then get something from those routes in your application logic. Nunjux is a Jinja templating engine. Nunjux is like close to abandonware at this point, but that's fine because all it needs to do is render Jinja templates. Jinja doesn't change really, and so this is done. It's a no dependency JavaScript file that just does Jinja for you. There's no reason. It is missing one feature that I wish that it had, which is template fragments, but other than that, there really isn't anything conceivable else that I could need for it to do. And then finally, htmx. I'm going to talk a little bit more about htmx at the very end. We talk about front-end, like extra application functionality. But for the time being, all you need to know about htmx is that it gives us access to put and delete, which HTML does not currently natively support. So this is for an application that I made for college, and it manages their outdoor trips. So it lets you, like, all of the students can like sign up for trips, the trip leaders can edit their trips, and the staff has some visibility into what's going on within the whole outdoor programs club. So I'm going to talk about these 5 routes in particular, which manages the attendance. It explains, like, somebody is coming on this trip, and the trip has left, and that all happens on this page. So let's look at the page real quick. So this is what the page looks like. It's just, there's a list here. I only have me on there, but that table can go for as many people who are signed up as the trip. And you can mark a person as present, and also you can check out the trip and say the trip has now left. So that page is rendered with this get function that you saw in the root previously up here. So there it is, trip/trip_id/checkout. And all it does is it gets this SQL query, which is 2 queries, one that gets the information about the trip, one that gets the information about the members of the trip, so who's going on it, and then it passes it to a template to render. A couple things to note about this. First, because we are using SQLite, because we are not making a network call each time we go to the database, we can use multiple SQL queries, which dramatically simplifies the query itself. So in fact, in all of the authentication for the routers, I hit the database to figure out if that user is logged in and what permissions that user has. That happens prior to any of this. But you can run, and this is the theory behind synchronous, it's also synchronous. This is the theory behind synchronous SQLite. The SQLite is so fast that we don't even need to bother with async. We can just do it really quickly, and we can do it multiple times, and it doesn't have the same performance penalty that happens when we hit the network on a client database architecture. So we run this SQL query, and we send it to a template. And this is what Nunjux does. This is Jinja. Jinja is a template format that I think originally came from Django, but is now available in basically any language. And it's just HTML with if statements and for loops and key value stores. So we can just pass some information to the template engine, and then it will do, like, for all of the members, put the member's name here, put this button here. So if you're familiar with HTML, the idea here is to write useful HTML while adding as little as possible to the semantics of HTML. So the reason I like Jinja is because it really adds very, very little to what is fundamentally HTML. So that renders this page. Now, some questions you might have. Where is the TypeScript? Where is the JSX? And are you really suggesting that we write raw SQL? There are basically 2 schools of thought when it comes to typing kind of the application layer. There is the first one, which is that you want to take whatever type system exists in your language, and you want to expand the boundaries of that so that it touches the database. There's an ORM there. It expands so it touches the template engine. We know what's allowed in the template engine or not. That's one way to do it. I don't think that, for the most part, any of the tools that allow us to do that have the same longevity properties that we can expect from SQL and HTML and the basic HTTP methods. So the philosophy that I'm going with here is to write as little application code as possible, so that all the application code is doing is very trivially taking the SQL statements and then, if necessary, which it isn't necessary at all in this case, reformatting them a little bit or adding a little bit of application logic such that they render in the template in a way that is intelligible. This is a trade-off between a world where everything is split up and componentized so that 5 junior developers can work on it at once, or you can be doing this, which I think has the quality of it's a little bit harder to modify. Yes, if I make a massive database change, that is going to be a problem. But again, we're building a bridge. We want to have some sense of stable requirements, and then we want to modify those requirements as our needs change over time. So this is the kind of thing that if I were a senior developer, I would a million times rather come to this code base completely cold than I would trying to get my hands around whatever abstraction brings the type system into the rendering of the HTML. And I think if we consider kind of the state of the industry right now and the macroeconomic conditions of it, I think it is a better bet to write code that 1 or 2 senior developers can show up to kind of cold than to write code for 5 junior developers to work on simultaneously, and then somebody has to reconcile all that later. So this is a button. I originally had a GIF here. The GIF didn't render. Oh well. The button where we mark that people are present. And that's kind of when you saw earlier, the members, the for loop that renders each of the people, it renders a button for each one of the people that is signed up for the trip. And this is the function for the button. So this is it's a put. And all it does is it writes the SQL that updates trip members and it sets attended equals true. And then if for whatever reason that doesn't match up with what was expected, if I coded this wrong, I'll get an error and I'll get a warning about it. But it'll do so silently because the client doesn't need to see that. And then I call the exact same getAttendance data function, which is the exact same SQL function that rendered the page, and I just render the table again. Some of that information isn't even necessary. I don't need to know the name of the trip to render the table again. But I don't care because the performance is so good that doing 2 SQL queries when I only need 1, it just does not matter. And so I'm able to kind of cast a wider net when rendering the page and also performing updates to the page. And this is the way the buttons are rendered. If the person is already signed up to go on the trip, well, then it gives them the button, or already marked as attended, then it gives them the button to remove their attendance. So let's say you marked somebody as attended, but it was a mistake. You click the delete button, and it will remove them. If they are not currently marked as attended, well, then it gives you the button to mark them as attended. And this is hypertext as the engine of application state. We don't need to talk too much about the theory behind it, but for practical purposes, what you're doing here is you are both telling the viewer on your client, hey, this person is not currently marked as attended on the trip, and you are giving them a button to do so. So you are describing both what is the current state of the application and what are the allowed actions that you can take to modify that state. And the mark not present, exact same thing, but in reverse. It's literally the same function, just as set attended equals false. If I wanted to, I could refactor this and just put set attended as a Boolean, but there's so little code here, I actually just don't think it's necessary, so I haven't done it. Every route returns either HTML or nothing with the appropriate status code. Sometimes I don't even bother to return a specific subset of the HTML. I just tell the browser to refresh the page. And because browsers, for the most part, if your page is fast enough, and this is really, really fast, if your page is fast enough, it won't even repaint the page. So the experience of refreshing the page or clicking on a quote-unquote hard link is identical to the experience of partially updating the page. And that's something that just quietly happened in the last 10 years with no fanfare. All of the people who wrote basically basic HTML got a huge performance upgrade in their browser, and everybody who tried to beat the browser now has to reckon with all of the JavaScript they wrote to emulate these basic features. With one exception, I have a calendar, and that calendar is a JSON route. And the reason for this is because I did not want to code my own calendar. That's a huge hassle, breaking it up into days or weeks or months. And also, conceptually, there's no need for me, when you mark somebody as present, you do need to hit the database for that. There needs to be a full round trip where before I say that this person is marked present, I, the user, don't want that button to flip until I know that that thing is confirmed in the application. But a calendar doesn't work like that. I can switch between weeks, switch between day view and month view, and there's no reason I should have to hit the network every time I do that. And so I just bought Full Calendar. And Full Calendar is you get a license and you can use it forever. And I just give it a JSON API. And so Full Calendar I load once with a year-long cache time. And I use a JSON API, and I just send it to Full Calendar, and I put a little shim here, div ID equals calendar, and I just say, do it. I don't care. It's all yours. And if in 10 years from now, I need a new calendar, or that calendar doesn't fit my needs for whatever reason, or maybe the vehicles don't have a calendar anymore, I'm not beholden to a whole set of build steps or a whole set of interconnected dependencies. The only place this dependency affects my application is on this one page. This doesn't load for every page. It only loads when you click the calendar page. So we're creating a set of interchangeable parts that make it possible to come back to this application 5, 10 years down the line and make modifications without worrying that those modifications are going to affect other parts of the application. And that application, those interchangeable parts are broken down along the lines of HTTP. So there's the calendar. And I've done this in typed languages too. This is a macro that I wrote in Rust. And this was hard. This was annoying. Tanner was talking about kind of getting types into a router. It's difficult, but it can be done. And if you need to use a language like Rust on the back end, or you need kind of complex types for something that your application does, well, it's doable. But you still have this very reliable set of abstractions that you can build towards. So the point isn't to like dogmatically say, well, you always have to use Express.js. The point is to say, this is what we're shooting for, and to the extent that your requirements support that style of building, the better. It's also way, way easier to debug. I have never had an exception thrown or some kind of bugged behavior where I was not able to identify within 5 minutes where that happened. If the SQL query threw an error, then I will just see a SQL error somewhere in my application. If there was a problem, if there was an exception in my application logic, it will throw me a stack trace that is exactly where that exception happened. Because there just aren't a lot of, I'm not going to get a stack trace to an ORM where I have to figure out what the ORM is trying to tell me about what happened with the SQL. It just happened somewhere, and the application tells me exactly where it happened. And HTTP gives you because HTTP and the methods and the response codes are visible at all layers of the stack. So if you use Nginx, you can filter based on response codes. If you're using some kind of logging, you can say, oh, I'm getting 500s, that's not good. You have far, far more robust and accurate debugging just because you're not throwing a bunch of stuff in between yourself and what's happening in your application. Okay, so application logic as much as possible in a router, and then whatever language gets out of your way for whatever you're trying to do for all the glue bits. And then finally, let's say you need to do something that is not supported by these basic HTML functionality, well, then you use htmx or kind of other isolated scripts. So we already saw kind of how we did that with the calendar on that one page. And htmx, if you're not familiar with it, basically gives HTML access to a couple extra primitives that it does not have right now, particularly as it relates to using more HTTP methods and adding declarative behavior to specific elements on your page. So it will let you make a declarative HTTP request and then replace whatever the server responds with right on your page. And that, in practice, lets you do all of the hard work of figuring out what should be on the page, on the server, and then just replaces it there. But I don't even really bother with that most of the time. I usually just do a post or a put or a delete and then redirect because that will have an identical, in modern browsers, in most cases, an identical UX, but it is much, much simpler to understand. And this is kind of how that works. If you've never seen it before, hx delete means when you click this button, delete that trip ID and that delete at that root. And you can see how this combines with Jinja so that I can have a specific URL for each person I want to do an action on. So we can use the semantics of HTML in a very granular way, as opposed to, say, having a remove from trip root and then somewhere in the body saying what we're trying to remove, we can put that all in the URL, and again, we can get closer to an ideal where all of the functionality of the application can be described at the router level. And just like with the calendar, one script, year-long cache, put the version in there so that it busts the cache if you upgrade the version. But I've built a couple applications like this, and I've actually just never upgraded htmx. It just works. And there's nobody's ever going to pester me to upgrade it because unless I try to build something that requires some newer htmx functionality, which at this point is pretty baked, we're not trying to do a lot extra with it, well, then it's fine. It's fine to be running htmx 1 point whatever. So finally, if we're trying to build this thing for 50 years, 100 years, we need to think about under what conditions would we replace the parts that we put in the application. So this is kind of just like an overview of some of those parts. Deno seems to be doing some interesting stuff. Maybe in 10 years, that will be a reasonable replacement for Node.js. Express, if there was a router that had Express's exact API, but better asynchronous exception handling, I'd switch in a heartbeat. SQLite, maybe in 30 years, we're using a better query language than SQL. If that happens, SQL's still going to be supported because we still have to deal with 60 years, or not 60, 30, 40 years of writing SQL. But maybe we want to upgrade that to a newer query language that we are relatively confident will have the same longevity guarantees. We can do that. But with htmx in particular, we are hoping to take some of the core ideas from htmx and just make them available to everybody. Because that is the work of increasing the tools that are available to the whole community and also increasing the foundation, the availability of kind of foundational elements that we can build with into the future. Because if it's in HTML, we're supporting it forever. So it gets access to that backwards compatibility, gets access to that universality. And we're doing this with a set of proposals called Triptych, alexanderpetros.com/triptych. The first one is out, and it has some pretty good traction. We're working directly with the teams, the relevant teams, to finally get put, patch, and delete support into HTML, which has a really long history of not being in HTML. And we're doing our best to, within the confines of what's allowed within a super backwards compatible standard like HTML, get that functionality in there because we think if we're going to be using HTML for 100 years, the fact that there hasn't been put support for 10 or 15 years, not that big a deal. And it still matters. It still matters for all the reasons I described in this talk. So right now, with HTML, CSS, with these technologies, we have access to stones and concrete. And those stones and concrete are really useful. You can build a lot of stuff that will be useful for a long time with stones and concrete. But possibly, in the near future, we might have access to steel. We might have access to, with the same degree of universality and compatibility, we might have access to more flexible, powerful paradigms. So that's the work that we're trying to do. I've got 3 minutes, so any questions?
Yeah.